So Geraldine couldn't be with us today, but we're all, the group of us are soil scientists with the USDA Natural Resources Conservation Service. She's with the Soil Survey Office, and I'm actually attached to the states, where she works more broadly across multiple states. So today we're going to be talking about our two representation of the Earth's surface. It shows size, shape, and interrelations of geomorphic features. And so here's one on the right. You can see it has a bunch of colors and lines and labels. And then you see kind of a flat version here with just lines and some numbers. And then we have one that kind of in the middle bottom is a block diagram. And that's more of kind of like a puffed up illustration looking at topographic map and the land surface together. So when we look at a topographic map, there's certain elements that are always on the map. There's a title, there's a legend with definitions that define the symbols. There are grid lines to show coordinates on the map, and those are in lat long. And then there's always a compass rose showing you the direction. So you're north, south, east, and west. Other elements are scale. You'll see either, you'll see both the verbal and a graphic scale. So you'll see it expressed as a specific distance on the map, and that's equal to a specific distance on the ground. So you'll see 1 to 24,000 here under that topographic map. So our example is 1 inch equals 100 feet. So that would be 1 inch on the topographic map represents 100 feet on the ground. And then there's graphic scales. That can be a bar or a line graph. And again, that just represents on the, you know, what you're seeing on the map equal to what's on the ground. So the fractional scale is, again, a ratio between distance measured on the map equal to what's on the Earth's surface. So, and it should spell out, and typically it is, you know, an inch versus, you know, equal to some same, you know, distance of units on the ground. And when you look at it, again, the topographic maps has colors and text on there, and what do all those mean? So we have water features, and hopefully you can see on here some of, they're all depicted, they're all in blue color. So it could be lakes, ocean, it could be streams. So you'll see some lines. So there's a creek that's blue. There's golden lakes that are all blue.
Debbie, we have a question. So Diane asked, when the scale says 1:24,000, what does that refer to? Miles, feet, kilometers?
So it will say on there. So here it says, this is, well, it's showing you different ones here. So this one's in miles. So here you can actually, if you wanted to take a measurement and know your miles, you would put, and the video describes this better than what I'm trying to say. It'll show you, you can actually put like a ruler or a piece of paper down to your scale, and then you can put that up against your map so you can see how many miles it is on your map. Here's another one in feet. So you can kind of measure, you can use this scale, copy the ticks on a piece of paper, and then you can push that up and around to your map so you can see how many feet it is to certain areas. So if you know where you're on the map as to where you want to go, say I want to go to this, is that Snow Lake? and I'm over here on Maple River, you know, I can measure myself either in miles, feet, kilometers. Does that make sense? So at least it's giving you a variety of ways you can tell how far off you are, or maybe how far you have to travel. So other things on the map, it's going to have features like roads, railroads. It'll have some boundaries. Here's a trail that's in dashed. What else? Relief. So all these brown lines are actually contour lines, and it's showing you the elevation at the darker colored lines, darker brown. Actually, you can see them, they have inserted numbers. So here, say above that, let me see, over by the trail, Wonderland Trail, just below that, you know, you can see there's a number there. So if you can follow that around. So those are feet. Elevations are given in meters or feet. I'm assuming this is in feet, even though I don't have the legend. And it'll give you spot elevations as well too, and those are shown in black. So see that sunset in the lower right-hand corner actually gives you that peak's elevation. So there's a lot of things on this map. And hopefully this video does better justice.
There was also another question asking what the numbers were in the water bodies.
Yep, those are probably most likely the feet, the level that they're at as well. That's their elevation mark. So if you look below trail, that's 4,800. You in each elevation mark, I know if I go to the one below, that's 4,600. So each one, and then it's going down, and then you could see that Golden Lake, the largest one's at 4,490. So you're going down in elevation to that lake. Does that make sense? All right, let's see if this video rolls.
There's no sound.
Ah.
I believe if you unshare and then reshare.
So hold on, what?
So if you unshare your presentation, when you go to press share screen again, there's a little click box that'll say like enable sound. So press share screen and then look at the box that comes up, and there should be like a little
share computer sound. Yep.
Yes.
Got it.
Nice. Good.
Now I just got to get back to where I am. All right, we'll start this over. You know what? Let me just go back to here. All right, see if this works.
Topographic maps are a little different from your average map. Not only do they show the location of things like roads and trails, but once you get the hang of reading them, they also help you visualize three-dimensional terrain from a flat piece of paper. Topo maps use three main mechanisms to describe the terrain. In this video, we're going to cover how to read the map's contour lines, how to understand scale, and how to read the symbols and colors found in the map's legend. Contour lines are what really make topographic maps something special. These lines connect all the points on the map that share the same elevation. By looking at how the contour lines spread out and come together, you can get a good sense of what the terrain looks like. When the lines are packed close together, that tells you that the elevation is changing a lot in a short distance, so the terrain is quite steep. As the lines spread out, the elevation changes more slowly, so the slope is more mellow. Contour lines can also help you visualize the shape of the terrain. For example, as the lines form smaller and smaller circles, they're probably showing a peak. Spend some time with a map of a familiar area and see if you can pick out terrain features just by looking at the contour lines. Every fifth contour line on a topo map is thicker than the others, and those thick lines are called index lines. At some point along every index line, you'll find the elevation for that line written on the map. The change in elevation from one contour line to the next is always the same on the map. And most maps have either a 40 or 80-foot contour interval. If your map has an 80-foot interval, that means that each contour line is 80 vertical feet away from the next. You can find all the specific details about the contour intervals and index lines for your map in its legend. Scale refers to the relative distance of the map. For instance, this map scale is 1 to 12,000. That means that 1 inch on the map represents 12,000 inches in reality. Another map of the same region is 1 to 50,000 and covers a larger area, but in less detail. The important thing is that the map with a smaller scale will show a smaller area, but with more detail. Understanding the level of detail on your map is handy when planning your route, but it isn't much help if you want to calculate distances efficiently. That's why maps also have a small representative scale near their legend. This scale shows you the relative distance of a mile or a kilometer on your map, and you can use the edge of a compass or even a piece of string to help figure out just how far away that peak is. One of the first things to look for on any new map is the legend. The legend is like the user's guide for your map. It's where the various lines, colors, and symbols are defined. When it comes to the colors on the map, the idea is that the darker the color, the denser the vegetation. As you get closer to the top of a peak, you'll notice that the colors get lighter as the forest thins out. And of course, streams and lakes are represented in blue. Alongside the list of symbols, there are a few other important pieces of information, like details about the contour lines and the date of the map's most recent revision. This is also where you'll find the magnetic declination for the region, which you'll use to set up your compass. When you combine your understanding of contour lines, scale, and your map's symbols and colors, you can almost visualize your whole trip before you go. The next step in becoming a backcountry navigator is to learn how to use your compass alongside your map. So click here to check out that video, or click here to find a navigation class near you.
All right, so everybody liked that video? Probably better than what I described, or a nice review. So let's go over again. I can't see chat, so if anybody's chatting with me. All right, so again here we have the topo map with the brown contour lines. And Geraldine put in a couple arrows. And it looks like she wants us to look at these thick marks that indicate depressions or drops in elevation, which are pretty cool. So if you're looking, taking a top view, you can see where it would go from 110 to 100 to 90 to 80 foot elevation. So there's a top view and then a side view of what you would be looking at. And then she has another one as well too. So it's pretty cool that you can actually, from a two-dimensional, hopefully you can visualize this a more three-dimensional view in your mind. And know that you're actually going into a depression and coming out. So I think she just wanted to show this one from Mount Rainier in Washington, which is pretty cool. It has a lot going on here. So hopefully you can, I'll throw out some questions and we'll see if you guys can answer them. So here we have the glacier coming down. Does anybody remember what the blue lines represent? You can throw it in the chat.
A river or
Yep,
water?
Yep, so there's White River, there's Wright Creek, there's another creek. Yep. What else do you notice on this map? Do we have brown contour lines? What are the black dots? What are the black text numbers and dots?
There's a scale.
Yep. Yep, it could be. So let's look at Goat Island Mountain. If I was, so I know south is headed down into my, from where I'm looking, north is up. So if I look at Goat Island Mountain and I'm looking kind of to the southeast, do you think that's steep, pretty steep terrain? And what?
Relief.
The contours are pretty close, right? You're going from the top of these at 72, just over 7,200, and it's going down pretty quick. I see 5,600, I see 4,800. That's a pretty quick drop, right? So it could be pretty steep there. What else do I see on here? Are there any campgrounds on this map? Where could I camp?
On White River Road.
Yep, there's a camp there. There's even a little backcountry camp by Glacier Basin. See, what else can I find? Let's see if there's any picnic areas, if I want a picnic. Does anybody see a picnic area? It's kind of hidden.
Near White River.
Yep. And I see there's a ranger station there too.
Can I ask something?
Mm-hmm.
What are those blue lines in the glacier? Emmons Glacier.
Yep, so that's also representing elevation, but it's in blue because it's ice.
Oh, okay.
Yep.
Thank you.
Are there any airfields? I don't think I see any. Can anybody tell me, maybe write in chat, what's the scale of this map? I'll give you a hint. It's right below Summerland. Yep. It's 1 to 69,500. All right, let's go to our next. All right, so here's a couple views of the landscape again. If this is looking from, if you set up a line from X to Y, it's going to cross all of those contour lines. And the second one, it's actually pulled out those elevations across that line. And then in C, you actually see it depicted. On another view. So you can, it's a nice visual of just looking at it two-dimensional versus, you know, kind of more three-dimensional. Having kind of an X, Y, Z. So here's another way to think about it. Here's a line from A to B. If I wanted to go, if say I'm hiking from A to B, here's my starting point down lower. And then I'm going to cross 1,220 foot elevation. I'm going to go hike all the way down. I'm going to come all the way back up, back down, and then it's going to kind of level out. And then I'm going to finish kind of down from where A is. So I'd be crossing the Tennessee River twice. And I'd be crossing the Raccoon Mountain Pump Storage. I don't know if I'd want to cross that. Or the river. All right, so she put together an exercise. Here's another topographic map. I got a couple questions for you. So first question is, what are the brown colored lines on the topographic map? Can you either put that in chat or you can unmute yourself?
Contour lines?
Yep. And what are the blue colored areas on the map?
Water bodies?
Yep. What kind of different water bodies do we have? I see some kind of lines. I see polygons. What would those be representing?
Rivers and lakes?
Yep. And then what about the green shaded areas? You remember on the video, they talked about the green shaded areas. You remember what they said?
Vegetation.
Yep, dense vegetation. And then they said the white areas are just are non-forested areas, you know, less dense. So it could be open land, grass, you know, grass, hay, lawns, something like that. All right, I think we are done. Here's the questions and there's your answers. And then we're also going to have some more exercises for you guys available on the Envirothon webpage that you can take a look at. So if you want to go through these exercises again, we'll at least we'll have those available for you. All right, any more questions on topographic maps, contour lines, any of the colors, the scale? If not, I'm going to move on to the web soil survey presentation. But we can always come back to these. All right, let me stop sharing and I will move over to the next one. Hold on, I just got to bring it up. All right, can you see that? Yes?
Yes.
Okay, sorry. I just can't see chat or anything. All right, so here you're looking at a beautiful piece of property and thinking that maybe you got a job helping the landowner plan for maybe a conservation practice, or maybe you want to purchase land to build a home, or someone wants to preserve the land. There's a lot of questions that soils information can help answer. So it can answer questions like, is this site subject to flooding? Is there a seasonal high water table? Maybe I want to know if there's prime or statewide important farmland soils on this property. And fortunately for you, soil scientists have collected a lot of this data for you to use. So a lot of this data was prepared and developed for many years through the National Cooperative Soil Survey, where the agency I work for, USDA Natural Resources Conservation Service, is the lead agency for mapping, interpreting, and distributing this soils data. And that cooperative, which a lot of could be private agencies, universities, other federal agencies, state, local agencies, all use these standards and protocols that are used to map and interpret the soil resources. And we distribute it through Web Soil Survey. So I kind of wanted to take you through a little bit of, you know, how these soil surveys are developed so you can understand them better and use them better. So as soil scientists, we use soil landscape or landform relationships to inform us of what soils are most likely present at the site. And knowing this and using various maps and imagery, we develop soil surveys. So we build our skills, and we're continuously building our skills to learn where to delineate soil boundaries. And we do a lot of digging, but we have a lot of good information that we don't have to go everywhere and get everywhere. So soil scientists all over the country have completed soil survey work that can be used by anyone. And on this slide, we have an image of a soil survey map and a map unit legend.
Hi, your PowerPoint isn't changing. We're still on page 1.
Oh no. Okay, let me see where I'm at here. Make sure I'm sharing the right one. Okay, let me stop sharing and make sure I'm sharing the right one. Hold on. Let me bring that up. All right, hold on. All right, let me back up. So did you see that? Can you see that flip now?
Yes.
All right.
Yes.
Yeah, it's changing now, Deb.
All right, so here was my great soil survey speech on how we look at landscapes and get down to a soil pet-on. This is what you should be seeing. So on this slide, you have an image of a soil survey map and legend. And the soil map shows soil boundaries or polygons labeled with a soil map unit symbol. So the legend shows the map unit symbol and the map unit name. It also has acres in the AOI, means area of interest, and it also has the percent of that area of interest. So for example, the soil polygon labeled BEBT on the map, I can use the legend and know that the map unit name is Beddington, Shaly Silt Loam, 3 to 8% slopes, moderately eroded. So what does this mean? Well, we'll get into that further. You can hit the map unit name, the blue one, and it'll give you more information. But before we do that, I want you to put in the chat box, using the map unit legend on the screen, type in what soil map unit has the most acres. All right, somebody said BKB2, you are correct. All right, so if you hit that map unit name, it'll take you to a soil map unit description. And so the soil map unit generally contains a major component, sometimes referred to as a dominant component. And it may have associated minor components that are considered other inclusions. Typically, these areas are too small to map, but they're recognized, in the soil map unit description. So under the soil map unit description, we find the soil map unit symbol, the BEB2, right? We have the soil map unit name, and that name lists Beddington, which is a series. And I'll get into that, what a series is, in the next slide. It also lists.
Hi, not to keep doing this.
I can't hear you.
There's a black bar. I don't know if you can see that's going up and down your slide.
And maybe it's probably our internet connection, and I can't do anything about that.
Okay, that's all right.
Sorry. I'm at the state office. I'm not even at home. All right, so we already did that one. All right. So looking at the soil map unit description, can anyone tell me if this soil is a prime farmland soil? And you can put it in the chat. You can tell me. Speak.
Yes.
Okay. Yep. If you look under the map unit description, it has the farmland classification. It says all areas are prime farmland. If you look, there's also something called that we have a series extent explorer. So here it has this Beddington soil, and it says how many acres are actually mapped. And it looks like most of this is throughout Pennsylvania. And then it has the red dots indicate how many pedons were sampled. We did lab sampling at those sites. So that's how we gather a lot of our information, is we'll actually go out there and sample these and then send them to our lab, our national labs in Lincoln, Nebraska. And then we get a lot of this, we get the information back, and then we put that into a system, and that's fed through Web Soil Survey so everyone can get that information.
Debbie, how big is a pedon?
A pedon is the smallest unit. If I go back, you didn't see this long enough. So here is our, so we look and map different landscapes, and we can tell that soils fall in different landscapes or landforms. And then when we pull this polygon out, or it's called our polypedon, we can pull out one individual unit, and that's called a pedon. So when we open up a soil pit, that all around me that is the pedon. But if you look at one side of this cube, it's actually, and that's what we describe as the soil profile. So we'll describe, so when I dig in a pit, I'm gonna have 4 sides, that's my pedon. But when I do my soil profile description, I'm usually looking at one of the sides.
Thank you.
All right, so I talked about series. So what is a series? A series is a group of soils with similar ranges and characteristics, and it's the lowest level of classification. So we classify soils like plants and animals, and we use the keys to soil taxonomy. That's our classification system. So if you looked across the United States, we have more than 14,000 soil series that we've described. And we, kind of like topographic maps, we can put them into these soil block diagrams that you see here. And then the names written there are soil series names like Canton, Sutton, Charlton. And we can see where they fall on the landscape. So I know it was a lot of information in a quick time, but at least you'll know if you're, looking in Web Soil Survey. Hopefully you'll know that when you pull up and you identify an area of interest, that you'll be pulling up a soil map, and you'll see the lines, you'll see symbols, and that there's an associated legend that can give you, remember, the map unit symbol, the name, and if you hit on that name, a lot more information.
Just a quick question. Back at your map where you had the different soils, can you see that by elevation? Are the same soils at the same elevation due to weathering, or is it just a different, can it vary widely?
They will change through elevation, because it depends on elevation. So here in Connecticut, we've done some looking at soil temperatures, and we've noticed a change in soil temperature at around 1,300 feet. So those have actually changed into other series, because temperature, climate is one of the 5 soil forming factors. So we really have to look at temperature and precipitation, and that will change.
Okay, thank you.
Yep. Good question. So this block diagram isn't passing any change in temperature or precipitation on these landscapes here. They're all in the same climate category. All right, so I'm going to quickly go through Web Soil Survey. Hopefully you've all tried using this, to hit the green Start Web Soil Survey button and navigate to your area. You can create import an area of interest. You can use quick navigation using an address, or if you know the survey area, or lat long. You can use, don't forget to use those 2 buttons that have AOI on them. You can do a rectangle or an odd shaped polygon. So here I've clicked my rectangle, I've drawn my rectangle, and this blue hash box appears that an area has been selected. And when that happens, these other tabs up top will actually open up. They won't be grayed out. So you can see my area here. The orange, it's not, the symbols don't show up so well. They're not, but they are there with the orange lines of my soil lines. I have my legend over here that has my symbols, my map unit name, my acres. I clicked on a map unit name and more information's come up about this map unit symbol 12. So in the chat box, using the map unit description that I have up, list what is one of the landforms that the Rapel series can be found on. Yep.
Can you repeat that?
I wanted you to tell me list one of the landform types that Rapel series is found. So if I looked under the map unit description, I go down to setting, there's actually a landform column there, and it lists depressions and drainage ways. That's where Rapel soils are found. So here's the bonus question. What is the typical soil surface, or the AP horizon texture of the Rapel series? Use the map unit description. The Rapel unit is opened up. I go down to typical profile. Yep, somebody said silt loam. So I see my AP, or the surface, it's 0 to 8 inches, and the texture is silt loam. So there's a lot of information in this map unit description, and a lot of times we'll ask you that on the Envirothon test, and that's where you can find a lot of that information. So it'd be good for you to kind of go through these yourself and kind of orient yourself as to where to find that information. So here we'll attempt to do an interpretation looking at water management. So I hit the Soil Data Explorer tab, suitabilities and limitations for use, and then water management. So you can see it still has my soil map up, but when I hit that interp, it's actually going to change the color of my map. And if I hit, so I hit view rating, it actually opened up my map and it gave me a table below. If I hit on the little legend tab, it can open up and I can actually see the soil ratings of the polygons. So can anybody tell me what is the rating of the red colored soil map units? So if I went over to my legend, I look at soil rating polygons, red reads very limited, very limited. That's right. So another tool you can use is called Soil Web. I kind of like this one just to look around and scroll around the map. And then you can hit on an area. So I hit this little red dot, here's where I selected within this 38C map unit, and it'll give you the name up top. It says Hinckley Loamy Sand, 3 to 5% slopes, 38C. It'll give you the map unit composition, and it'll give you some more map unit data. And it actually gives you a nice typical profile picture of the soil profile, which I think is pretty cool with the colors of those horizons and depths. And it gives you the horizonation on them too. So this is something you can put on your phone and use. And then in the upper right-hand corner, if you want to go into Web Soil Survey, you can quickly link to Web Soil Survey if there's an area that you want to look closer at using that app. So there's a couple different ways to look at soils data. So this is what the app looks like on your phone. If you download the Soil Web app, you can hit Get My Location, and it'll actually bring up just the soil profile picture. And then you can look into the series description and then some more information. There's also another way to get to Soil Web, and that's just by opening up your browser and then going to, and then just searching for Soil Web. And then in that way, it'll open up this map, which you can say, Get My Location, and you'll actually see the map on your phone. So just good ways when you're out in the field, you know, to kind of take a look at the area. So if you're going to a competition and you forgot to look at the area, you can pull this up on your phone, not at the station because you won't have your phone, but before you get there on the bus, you can take a look and kind of do some quick looking and reviewing of that information. So just a reminder, what we went over today was key point 5. We looked at topographic maps and soil surveys. And we have a couple exercises with the answer keys on there, so you can kind of go through some stuff yourself, either, you know, on the topo map or do a web soil survey exercise. So I think that is all I have today. Let's see, I have one more slide. Oh, I brought this up because I saw this recently, looking at different ways to look at a map, and kind of liked it because it said which symbol property best represents the different city populations. So remember, when you're looking at a map, you know, things were put there, you know, especially to represent something to, well, to enhance how it is represented. So whether it is a color or a text or a size of a symbol, they're all very well thought out on how to represent those different types of information that you're trying to get across on a map. So just something to think about. Any questions on web soil survey, topo maps? I think I can stop sharing. And maybe I can see the chat. All right, well, that's, you know, I think we've gone over more than what we would typically do, you know, at an Envirothon workshop person. We actually do more in this virtual. And, you know, you're also getting the materials online too that you can go over yourself and do some online using web soil survey. All right, is anybody going to use this information in their reports too? Don't forget, you can use this information when you're doing presentations, your oral presentations.
All right, so if anyone has any last questions for Debbie, feel free to either unmute yourself or type in the chat box. Additionally, if you have any questions about any of the other workshops this week, formats, or anything you'd like to see in the future from either the soil workshops or any of the other workshops or any of our formatting, please either type in the chat box or unmute yourself. Other than that, I think, Debbie, if you have anything else to add.
No, I think we got done on time, and
Thank you. Goodbye.
bye.